Molweni, grade 12 physical sciences learners. The topic for today is on electrochemical reactions. Get hold of your examination guidelines 2017. Study and master physical sciences textbook grade 12 or any other grade 12 CAPS physical sciences textbook. Table of standard reduction potentials, but I'll be using 4B from the previous question papers. I would like to start this topic by revising grade 11 redox reactions. In grade 11, the emphasis was on direct transfer of electrons. The practical example you did in grade 11, you add zinc powder into the ionic solution of copper sulfate. The reaction is as follows. Copper sulfate in aqueous form reacts with zinc in solid form in order to form zinc sulfate in aqueous form plus copper in solid phase is brownish. When assigning the oxidation numbers on top of the equation for the reactants, +2 for copper 2 plus, +6 for sulfur, -2 for oxygen, +0 for zinc in solid form. Then for the products, +2 for zinc 2 plus, +6 for sulfur, -2 for oxygen, and 0 for copper in solid form. Reduction is indicated by a decrease in oxidation number. Reduction is indicated by a decrease in oxidation number. Copper 2 plus has decreased to copper 0 in oxidation number. Oxidation is indicated by an increase in oxidation number. Zinc in solid form is having the oxidation number of 0. The oxidation number has increased from 0 to zinc 2 plus to 2 plus. Writing the half reactions. Reduction half reaction. Copper 2 plus are reduced into copper by gaining 2 electrons. Reduction half reaction is copper 2 plus in aqueous form plus 2 electrons forming copper in solid form. Reduction is the gain of electrons. The memory aid you can use, RIG. Reduction is gain of electrons. Then the copper 2 plus is the oxidizing agent. An oxidizing agent is a substance that is reduced, gains electrons. Copper 2 plus is an oxidizing agent. And the oxidation half reaction. Zinc in solid form is oxidized into zinc 2 plus. Zinc in solid form loses 2 electrons. Oxidation is the loss of electrons or transfer of electrons. Zinc in solid form forming zinc 2 plus 2 electrons. The memory aid you can say oil oxidation is loss of electrons. Reducing agent, a substance that is oxidized or loses electrons. Zinc is the reducing agent, loses 2 electrons to form zinc 2 plus. Then when using the table of standard reduction potentials 4B, write the reduction half reaction as it is from the table of standard reduction potentials. Omit the reversible sign equation and have a forward reaction sign only. For oxidation half reaction, in the table 4b is on top. The one that is undergoing oxidation is on top. Reverse the equation with no reversible sign. For the redox reaction, balance the number of electrons. They must cancel each other as shown below. Reduction half reaction. Copper 2 plus 2 electrons forming copper. Then oxidation half reaction, zinc in solid form forming zinc 2 plus 2 electrons. Redox reaction is copper 2 plus zinc in solid form forming a zinc 2 plus copper in solid form. In grade 12, electrochemical reactions addresses the industry, so they are more on application. In grade 12, you consider indirect transfer of electrons. You are doing at the galvanic cell or the voltaic cell. The majority of textbooks are having an illustration of this practical activity. Put an ionic solution of copper sulfate in one beaker and an ionic solution of zinc sulfate in another beaker. You have put the electrolyte of copper sulfate and the electrolyte of zinc sulfate. An electrolyte is a substance of which the aqueous solution contains ions, or a substance that dissolves in water to give a solution that conducts electricity. These two electrolytes, copper sulfate and zinc sulfate, are separated by a salt bridge, U-shaped tube, on page 230 of your textbook. Salt bridge is filled with saturated salt solution in a solution like potassium chloride, potassium nitrate, potassium nitrite, or ammonium nitrite. You can use any of these salts, and then you use a cotton wool to close at the ends of the salt bridge. Then at the functions of the salt bridge, a salt bridge completes the circuit, separates the two electrolytes so that they do not mix, provides a path through which ions move to restore neutrality and ensure that the electrolytes remain neutral. Salt bridge and electrolytes form the internal circuit. Then with the external circuit, put electrodes into the electrolytes and connect them to the voltmeter or galvanometer. It's cheaper to use the carbon electrodes. They are inert electrodes, meaning they do not participate or interfere in the chemical reaction, but serves as a source of electrons. Negative electrode, cathode, is connected to the positive terminal of the voltmeter or galvanometer. Positive electrode, anode, is connected to the negative terminal of the voltmeter or galvanometer. The process from the internal circuit, reduction occurs at the cathode. Reduction is the gain of electrons. Oxidation occurs at the anode. Oxidation is the transfer of electrons. Electrons are transferred from the anode to be received by the cathode. Energy involved is the chemical energy, causing deflection in the voltmeter or galvanometer. Therefore, the chemical energy is converted into electrical energy in the galvanic cell or in the voltaic cell. So then you can say that the galvanic cell or the voltaic cell is the cell in which chemical energy is converted into electrical energy. Galvanic or voltaic cell has a self-sustaining electrode reactions. Enough for the day.